Good morning again to all of you. I have the pleasure and the honor also to moderate this very interesting session. We are going to have three keynote speakers, and I'm going to introduce them. The first one is Dr. Ignacio Gomez from University of Cordoba, who earlier on during the morning gave us a very interesting presentation regarding the possibility of using treated wastewater for irrigation of olive orchards. And today he will talk to us about risk management paradigms shaping agricultural water use regulations, a comparative international review. So, Ignacio, the floor is yours. Thank you.
Thank you, Marco. I hope to be doctor next year. Not yet, but it's a wish. Yes, thank you. So yes, I'm going to present the results of this study that we carried out with our colleagues from French INRAE. Nassim is over there. So let's get to the topic. As we said before in the other meetings, we all know here that reuse is necessary. So I just want to add a fact that I haven't heard during the morning nor yesterday, and it is that irrigation is necessary. Moreover, to feed a population that will surpass 10.4 billion inhabitants by the end of this century. So despite its bad reputation, its bad press, irrigation is necessary. Here is a very interesting fact. Only 18% of the cultivated land is irrigated, but it produces 40% of global food. So irrigation, again, is necessary, and in this context of water scarcity, agricultural water use can contribute to ensure a reliable and stable supply for farmers, which can help guarantee stable productions, which is very interesting. Also, agricultural water use contributes to the circular economy, and its high nutrient content reduces dependence on synthetic fertilizers. Nevertheless, agricultural water use conveys risks. For example, we have environmental concerns, such as the accumulation of PFAS. We have health risks derived from the presence of pathogens and parasites in reclaimed water. And we have also agronomic issues, such as salinization or crop toxicity. So the risk management approach is what shapes reuse policies and differentiates them from one another. So the question here is, how do reuse policies deal with risk? And in this sense, there are two key concepts that policymakers aim to balance and which show an opposite relationship. On the one hand, we have safety, and on the other hand, we have feasibility. And slanting excessively towards safety may result in impractical standards, too expensive reclaimed water. But on the other hand, opting excessively for feasibility may lead to mistrust, public health issues, and safety concerns. So finding the middle ground between safety and feasibility is necessary. First of all, we should also distinguish between the terms hazard and risk. A hazard is something that has the potential to harm us, for example, a shark in the sea. But as long as there is no exposure, I'm not at risk. So what transforms a risk into a hazard is the exposure. And that's a very interesting concept when we are comparing reuse regulations, because the exposure assessment is a key concept. We have two main contrasting approaches. We have the hazard-based policies, which aim to ensure a high-quality effluent due to prescriptive standards. We have monitoring obligation, rigid quality thresholds, in order to gain public trust and increase the confidence in water use. These policies are ruled by an end-of-pipe verification model. So the water utility is also responsible for ensuring the water safety. So we perform a water quality test at the outlet of the plant, and we determine whether this water is suitable or not for agricultural irrigation. So this binary pass or fail logic make these policies easy to enforce and easy to check for compliance. But as we all know, these policies are resource intensive, they require appropriate infrastructure, appropriate technology, and they may not be suitable for every reuse project. On the other hand, we have the risk-based approach, which is characterized by more flexible quality requirements in order to make reuse also feasible and affordable. These policies are based on the exposure assessment and on those response models. They are influenced by health-based targets. For instance, what's the highest concentration of this pathogen or of this chemical that I can tolerate without detrimental effects. So the approach is completely different from the hazard-based. These risk-based policies incorporate the concepts of the multiple barriers and the fit for purpose, not to rely exclusively on water quality improvement by treatment. And a negative concept here is also the shared liability, because all the actors in the reclaimed water chain contribute to risk mitigation. For instance, the water utility is responsible for treating wastewater, the farmer is responsible for stopping irrigation 2 days before harvest, and the consumer is responsible for peeling the products and cooking them. So this shared liability makes these policies difficult to enforce and make it difficult to check for compliance. That's one of the reasons why most risk-based policies are issued in the form of guidelines, as we are going to see now. I present here some examples of hazard-based policies. Here I chose the California water recycling criteria and the Jordan and Israel regulations. And as you can see in the third column, all of these policies are issued in the form of regulations, because whenever compliance must be verified, usually by governments, policymakers tend to adopt these hazard-based approaches because it is easier to check for compliance and to make them enforceable. Here we have some risk-based policies. I chose some iconic guidelines, the WHO guidelines, the FAO guidelines, and the Australian guidelines for water use. And as you can see in the third column, all of these policies are issued in the form of guidelines, because checking for compliance is very difficult due to this reliance on multiple barriers and this shared liability. Therefore, risk-based policies usually provide guidance on how reuse practices should be conducted, but it's difficult to implement them in the form of regulations. So, well, it's been a bit moved, but no problem. As we've been discussed a bit, fully risk-based and fully hazard-based schemes present some limitations. In the case of risk-based policies, for instance, the fit-for-purpose approach is a good idea, but it's difficult to implement in reality because water utilities usually provide reclaimed water for a wide variety of crops. Therefore, they usually comply with the most stringent category because it's not feasible to make 4 different kinds of reclaimed water. And also, as I said before, they are difficult to enforce due to this shared liability and this heavy reliance on multiple barriers, many of which are behavior-based. For instance, how can we check if the farmer has stopped irrigation 2 days before harvest? So this kind of compliance make them very difficult to enforce. On the other hand, we have the hazard-based approach, which is characterized by huge investment, reliance on technological equipment. Therefore, reclaimed water is usually expensive to produce. It may not be suitable for every reuse project. And the last point is also very important. In order to gain public trust, policymakers tend to adopt sometimes disproportionate standards, treating reclaimed water nearly to potable drinking levels, which, in my opinion, for irrigation makes no sense. So in this point, we have seen hazard-based and hybrid approaches. We could ask ourselves, how do hybrid approaches deal with risk? And I brought here the example of the European regulation and the ISO standards, which are very similar. And they aim, this is very beautiful, this figure, but they try to pursue it. They aim to bridge the gap between fully risk-based and fully hazard-based approaches by incorporating both hazard-based and risk-based features. For instance, if we look at our European regulation, we have hazard-based traits to ensure safety and to build public trust. For instance, we have fixed quality thresholds for our 4 quality classes. We have binding monitoring requirements. And we also have a compliance-based approach. It is true that with the implementation of barriers, we can soften a bit the quality requirements, but still we have this hazard-based trait in order to build public trust. But at the same time, we also have some risk-based features, such as the fit-for-purpose and the multiple barrier concepts, that help reduce the dependence on water treatment. There are other ways to ensure safety, not only water treatment in the water utility. And we also have, very important, the last concept, the site-specific assessment, which is embedded in the risk management plan. But still, implementing hybrid approaches, as we are going to see now, is not enough to guarantee the successful implementation of reuse, and we are going to look closer at the case of Europe. Well, this has also been moved, but the first question that we should ask is, how are the other water sources regulated? because people tend to think that surface water from a river is always safer than reclaimed water. And in my opinion, it's also very important to demystify reclaimed water. So I brought here a site from Professor Haberkamp from the University of Münster in Germany, and I totally agree with what he says, and it is that the implementation of water use is only economically attractive if we also rule with similar regulations the conventional groundwater and surface water, because otherwise the playground is not fair. We are overruling reclaimed water, but the conventional sources are not being paid enough attention. We could also ask ourselves that what's happening in Europe with the indirect reuse, and if our rivers contain fresh water. I present here some slides from a very interesting study that the University of Munich performed, where they quantified the percentage of wastewater treatment plant effluents in European rivers. And they found that in dry periods, there are many wastewater-dominated streams, and I present here some examples. This is in the Llobregat River in Barcelona, which in some dry periods is made up of more than 80% of wastewater treatment plant effluents. So is this water fresh water? That's a good question. But this does not only happen in Spain, it also happens in the north of Italy, for example, in the region of Bergamo. It happens also in the south of France, in the region of Montpellier. So we see that there are many European rivers that are dominated by wastewater treatment plant effluents. And still we consider these sources as fresh water. So with these slides, we could also ask ourselves, what's the concentration of E. coli in these rivers? And I brought here some studies all over Europe which show astonishing figures, here surpassing 1 million, 1,000 colony-forming units in a river in Greece, but also in Germany. Here, for example, we have a rural area, an industrial area where the river shows a concentration of 7,000 colony-forming units, and this water is widely used for irrigation without such stringent controls. Also in France, in Spain, all over the Mediterranean region. And we must acknowledge that, for instance, in many Mediterranean countries, for instance, Spain, Egypt, or Italy, surface water is the main source for irrigation. So we are using water for irrigation that is considered fresh water, but the indirect reuse is a huge reality in our basins. Here I also brought a very controversial slide, because here we can see two policies issued by the same institution, the European Union, but they tell us completely different things. On the left-hand side, we have our European regulation for water use, and on the right-hand side, we have the European Bathing Water Quality Directive. And according to the European Union, swimming in a river or a lake with a concentration of 500 units of E. coli is safe. That's an excellent quality. But then for irrigating a lettuce, we need to have 10 or less colony-forming units of E. coli. So we could ask also ourselves, where is the risk of exposure higher? By swimming in a river where you can accidentally swallow water, or by eating a lettuce that is going to be washed, that is going to be refrigerated? So I'm not saying that the requirements for water use are disproportionate, but I'm saying that these two policies tell us different things and that they do not match. So coming to the end, I wanted to present here also some thought-provoking questions. The first one, which is usually forgotten by many policies, is the concept of cost recovery. How are the costs of reuse managed? And in this sense, I think that we should look at Cyprus, which is the country of the European Union with the highest rate of reuse, because there, for farmers, it is cheaper to irrigate with reclaimed water than with conventional groundwater, because reclaimed water is highly subsidized by the government. So that's an interesting way of making reuse attractive for farmers. Because otherwise, and answering to the second question, farmers are not going to accept a shift from conventional water to reclaimed water, which is usually more expensive, without any kind of financial incentive or subsidy. And coming to the last question, that's a thing that's happening a lot in my region, in Andalusia. If reuse is not economically attractive, the real demand for reclaimed water comes from farmers who lack water rights, comes from farmers who do not have access to water and are willing to pay the price of reclaimed water. That's a study that Alfonso and Antonia also developed. So I think it's very interesting to pay attention to this concept, because these substitution policies of the European Union, we want to reduce the pressure on fresh water, but if we do not make reuse attractive, it's going to fail. And I also like to share always this slide here, because as Pedro Simon told us yesterday in Murcia, part of the solution, I mean, the guarantee to the successful implementation of reuse comes also from understanding that reclaimed water is part of the solution, but it's not the solution itself. It's not a miracle. So in Murcia, you can see here that reclaimed water contributes nearly 10%, that's the Segura River Basin, to the total freshwater demand. And as you can see, they have diversified their water mix, which makes them very resilient to droughts, to dry periods, because they can easily adapt. They do not rely only on one source. They have desalinated water, they have reclaimed water, groundwater, surface water, the transfer. So this water mix makes them very resilient to water shortages. And finally, some take-home messages. The first one is that reuse policies should not frame reclaimed water as a threat to be managed, but recognize it as a reliable water source that, if it's governed by coherent and context-appropriate frameworks, can contribute to adapt agriculture to climate change. The second one is what Professor Haberkamp said: as long as the other sources, the conventional sources, are not ruled and controlled by similar standards, reuse policies are not going to be an interesting alternative because the playground is not fair. Also, making reuse economically attractive is key to achieving its successful implementation. Here we should look at the example of Cyprus, where reclaimed water is very attractive in terms of economy. And finally, ensuring safety is key, but if it is done without assessing feasibility and the adoption by farmers, it may be counterproductive, leading to the failure of the substitution attempts, as we have seen, leading to an increase of the total water demand, and in the worst case scenario, leading to illegal and planned reuse. So here, policymakers should bear in mind that safety is as crucial as feasibility when we are talking about reuse. So I wanted also to acknowledge the Cost Action Water for Reuse, as they have supported this speech with a conference grant, so thank you. To the Water Sudoy project, and to the Spanish Ministry of Science, Innovation and Universities for awarding me with a grant to perform my PhD. And also, thank you all for your attention.